Hello, I am Gerard, your host here at Falling Entropy. Today, Jason, the founder of Falling Entropy, is joining me for a brief discussion of how the science of rheology is very significant to 3D printing.
Hey Gerard, thanks for the introduction. So first of all, what exactly is rheology?
Great question, Jason. Simply put, rheology is the study of the flow of matter, most often with liquids and semi-solids, important to many manufacturing processes, including 3D printing. For example, a widely used 3D printing technology known for its simplicity and affordability is fused deposition modeling, or FDM. It works by melting and extruding a thermoplastic material, like PLA or ABS, through a nozzle, which then deposits the material in layers onto a build platform. A challenge that the science of rheology helps with is creating materials and conditions that allow the material to flow like a liquid or semi-solid out of the nozzle, but then quickly turn into a solid on the build plate so you get a stable print.
So could you describe some of the rheological properties of matter that help with this issue? How does the material not get clogged in the nozzle yet solidify so fast on the build plate?
Rheology helps determine factors like extrusion, shape fidelity, and printability. One of the primary properties is viscosity, or the resistance of a fluid to flow. Too high of a viscosity can lead to nozzle clogging, but too low of a viscosity can lead to poor shape retention. Another important property is whether or not a material exhibits shear thinning or the decrease in viscosity as the shear rate increases. In other words, when a high-pressure force is applied to a shear-thinning material in the nozzle, its viscosity will decrease, allowing it to flow more easily. But when that pressure force disappears once the material is on the build plate, the viscosity of the material returns to its higher undisturbed value, which prevents it from flowing, which helps it keep the intended shape while cooling and solidifying. A related property is known as thixotropy, which characterizes how fast a material will recover its viscosity once the shear force is removed. Ideally, you want the viscosity to recover quickly so that the current layer will solidify before it's time to print the next layer on top of it. Other important properties are material yield stress and viscoelasticity.
So it occurred to me that a lot of home cooks or chefs are familiar with rheology, like when making gravy or sauces like ketchup. You don't want it too thin. You also don't want it too thick that you got to cut into it, right, Gerard?
That is correct, Jason, and it is also a challenge for food 3D printing. But we will save that for another day. Until next time, keep 3D printing.